Okay guys, so actually before we really start the session, just want to double check that everyone's cool with the kind of the setup. So let's just go through our checklist here. Everyone's got Docker obviously. Does everyone have SSMS, SQL Server Management Studio? Got that installed? Cool. Everyone's got Git? Yep. Everyone is comfortable using Git, right? And everyone's done the Docker pools that we listed on the page? Yep, cool. And we've got some more people arriving. Have you guys all cloned the Git repo? There's a Git repo there, cool. And we'll just wait and see if those guys are joining. No? Okay, cool. And so anyone who's planning to do the AWS exercise, our last exercise will be AWS. It's really up to you guys if you want to join with that or if you just want to kind of observe. So who's like going to join that? Okay. Okay, a few people? Okay, cool. Just so I know, because when we get to that point, I'm probably just going to have to help you a little bit more because there's a lot of moving parts with the AWS part. So, cool. All right. So, yeah, welcome everyone to our Docker presentation. This presentation has actually gone through a few iterations. It was originally called Introduction to Docker for .NET, and it's kind of expanded now to the point where it's not just introduction now. So I've kind of just called it Docker Fu, as in Kung Fu. Before we get into it, I'd like to actually say, I mean, on behalf of everyone here, thanks to Agoda for providing this venue and making this event possible. I think it's really cool what Agoda is doing for the Bangkok tech community. So I think we're quite lucky to have this pretty cool space to work in and have this chance to get together and learn about Docker together. So just to briefly introduce myself, my name's Brendon. My nickname is Bren. I'm Australian, but I've been in Thailand for about 11 years, a bit over 11 years. And I started programming on one of these way back. It's a Commodore VIC-20 when I was 6, 3.5K of RAM. It was a great machine. And these days I work, as Tim mentioned before, I work in healthcare IT for Orion Health. And aside from that, I like playing with multi-tenant software as a service. And recently I've been working with a bit of functions as a service, just as I've been dabbling, I would say. With that, as I mentioned, this presentation originally was introductory, but I really want to go, for you guys, I'd like to go much further than just introduction. There's a ton of like Hello World kind of presentations on YouTube. If you want to just get the basics, you can easily get that from all the different presentations that are out there. So I want to try to give you guys a chance to go a lot deeper today than just Hello World. So we're going to try to, as in the Matrix, download as much knowledge as possible so that you guys are really well armed to start using Docker for your work back at your places of work. So the plan for today's session is we will go through basics. We'll actually do the Hello World sort of level stuff because we've got a variety of knowledge levels in this group. So just to make sure everyone's on the same page, we will go through the basic stuff, but we'll very quickly start to work with a real, well, I would say real in quotes, application, which is a .NET Core web API based application. And we will start to Dockerize that and play with that on both Windows and on Linux containers. And then from there, we'll take that application and we'll start to turn that into a production style configuration. So setting up a multi-container solution using Docker Compose and then running that on a cluster using Docker Swarm. And then we'll kind of cap that off with running that same or a similar kind of configuration on Amazon's container service, ECS. And then we'll wind down with a few discussion points about some other tooling that comes along with Docker. So starting off, of course, with what is Docker. So if you're new to Docker, the way I would recommend you think about it is as a packaging, deployment, and execution tool. So that's not one thing, it's actually a few things. It handles packaging your application, deploying your application, and helping you to run your application in production. So Docker attempts to solve a number of problems that we all, I'm sure, have faced with managing software. The first problem is environmental differences. So I'm sure you guys, and I know I've said these famous words, you guys have faced a situation where you say, it works on my machine when you get a bug from production. And the reason it works on your machine but not in another environment is because there's some difference between your dev workstation and whichever environment it's failing in. So those environmental differences are really subtle. They're often extremely time-consuming to figure out, extremely just annoying, actually. So that's one problem that Docker tries to deal with. Another problem is complex deployment processes. So as your software gets more and more complex, more and more moving parts, you've got some APIs, you've got a database, you've got a cache, you've got front-end web servers, you've got load balancers. every time you add another moving part to your system, it gets more complex to deploy. You've got more steps to go through. You can try to automate that, but even automating that can become quite challenging, and Docker tries to make that a little bit more streamlined for you as well. And another problem is conflicting dependencies. So if you've got a server and you're trying to run your software on that server, if your software requires a certain version of a dependency, whether it's a library or even an OS service, and another piece of software you need to also run on the same machine has a different version or a conflicting requirement about the dependencies, then you can have a tricky situation trying to reconcile that. So Docker's solution to all these problems is, and you'll see thousands of pictures of containers as you start to play with Docker, is this metaphor of a container where we basically try to isolate our software inside of a container. So, and this metaphor really does work quite well, and I think it resonates with us as developers as we start to learn about it. You've got this container, you put your software into the container, and it's now isolated, so your software won't interfere with software running in other containers and vice versa. And you can also bundle any dependencies that your software needs into the container with your process. So you can get over that conflicting dependencies problem. And by building your software in containers, by definition now, your software has now become defined in this container, which you can now relocate to different environments. So you can run it in dev, and you run the same container in production or in test. And so that problem of environmental differences and the works on my machine syndrome kind of goes away by definition with Docker. Just a little point about Docker adoption. I think that Docker has really become now, although it's not really, reached critical mass, I think you could say, it really is a critical tool, I would say. So every developer, every tester, every ops person really needs to be learning about Docker because it has so many benefits in terms of solving those problems that we just talked about for everyone involved in creating and deploying software. So this slide is from that Datadog page there. This is from early 2017. So you can see the curve of adoption is really, increasing. It's still only, in terms of adoption, it's probably about 25–30% of companies have adopted it for production. But so we're still kind of in that early stage of getting traction. But again, I think it's a critical tool, and it will get to that critical stage. So you guys have made the right decision coming to this presentation today. Let's talk about how Docker works at a technical level. So Docker has a Linux heritage, actually. Containers have actually been around for about 20 years in the Linux world, and they came about as there was a series of improvements made to the kernel that allowed you to do more and more isolation of processes on the Linux kernel. So containers have been around for a long time in Linux, but they really only took off in popularity with the advent of Docker, because Docker really makes it much more accessible, easier to work with containers on Linux. So let's just talk about how containers work on Linux. So with Linux, you've got the Linux kernel that has that capability to provide isolation, container isolation for your software, basically to define containers. And onto Linux, we install the Docker engine, and we use a front-end tool such as the Docker CLI to basically control that Docker engine. Actually, the Docker engine just has a REST API, that you can talk to. The Docker CLI can talk to that REST API. And there's a lot of other tools as well that also talk to the Docker engine's REST API. And you can also write your own tools as well. It's an open API. So we use the Docker CLI to control the Docker engine, and the Docker engine will then basically start up our containers on the Linux kernel and manage their lifecycle for us. This is like a physical machine, let's say, but we can also run this on a virtualized infrastructure. So if you've got a hypervisor, whether it's VMware, Hyper-V, or any other hypervisor, you can also run Docker inside of virtual machines. So the same process applies here. For Windows, it's a little different. Because Windows doesn't have that heritage of kernel support for process isolation for containers until very recently, there's two models in Windows at the moment. So the first is on Windows Server 2016, which I think came out last year, if I remember correctly, finally G8. So Windows Server 2016 does have the kernel support for containers. So there's a concept of Windows containers, which is the equivalent of Linux containers. So if you're running Windows workloads on Windows Server 2016, you do get the native kernel support. The second model is Hyper-V isolation. By the way, we're going to see this in more detail as we get into our practical examples. The second model is Hyper-V isolation. So here, where you've got an OS that doesn't provide the kernel support that's required, Docker can basically, in the background, transparently create a Hyper-V virtual machine that does provide the kernel support. And this is if you need to run Linux on Windows, or if you're running, let's say on Windows 10, as we are today, we're all running Windows 10, then you don't have the kernel support, so transparently in the background, Docker creates a Hyper-V VM for you to run that. So two models for Docker on Windows, and there's some links there for further reading on that. So if you're using Windows Server 2016 and you're running a Windows workload, it's really the same model as what we saw for Linux. So you've got Server 2016, the kernel provides the container support, Docker Engine orchestrates that for you. This also works if you've got, I think it should actually just say Hyper-V. Hyper-V is your hypervisor. Actually, no, this would also work for VMware. You can run Windows Server 2016 VMs and run Windows workloads directly against the kernel. If you're using Hyper-V isolation, so you've just got that additional layer of Hyper-V between the kernel and your software. So Docker will orchestrate creating a VM for you, and then it will orchestrate running Docker inside that VM and running your containers inside the VM. And this also can be done on Hyper-V. So there's this concept of nested virtualization where you've got Hyper-V, you've got your VMs, and then Docker will actually create VMs inside your VMs on a nested Hyper-V to run Docker images or Docker containers inside those nested VMs. Okay, so I just want to make a comment about, we talked about virtualization and containerization. So I want to make a comment about contrasting these two. So when you first come into Docker, it's quite natural to think of Docker as a virtualization technology and to think of Docker containers as like mini VMs. And certainly that was my mindset when I started to learn about Docker. It's really not the right way to think about Docker. Docker is not a virtualization technology, it's containerization. Two different things. So let's contrast virtualization and containerization. So with virtualization, actually you're creating a virtual machine. You've got virtual cores, disk, RAM, devices. Whereas with containerization, you're using the native hardware. So you only have your host machine. You don't have a virtual machine in between your host machine and your process. You're running on the native hardware or native virtual hardware, and your host kernel is used by your container. So there's nothing between your process and the host kernel. You can control resources. So one of the cool things about virtual machines, when that came about in the industry, virtualization enabled us to really allocate resources to different workloads. So you might set up a really huge physical machine and then start to allocate portions of that machine to different workloads by creating virtual machines to allocate a certain amount of RAM, a certain number of cores to your web workers versus your database and so forth. You can still do the same thing with Docker. So you can use control groups and other mechanisms to control how much RAM, how much CPU time each Docker process has access to. With virtualization, you actually install a guest OS into the virtual machine. Again, with containerization, you don't do that. You've got the native kernel is all that you're running on. All the supporting software you need that would otherwise be coming from the OS or from libraries that you install are bundled into the container, as we mentioned before. So kind of in summary, my kind of bullet points, my summary for this is VMs are like system-oriented and containers are service-oriented. And that's really the key point. When you're going into Docker, think about your software as a set of different services. Each process should be basically a separate container. Don't try to put your database and your web workers and anything else into a single container. That's really the mistake you'll make if you think about Docker as a virtualization technology. Okay, so let's start getting into some hands-on Docker basics and start to see what we've just talked about in practice. So obviously in software, the first thing we like to do is hello world, printing hello world to stand it out. So let's do that with Docker. What you'll need is either a command prompt or a PowerShell. I'm using just a command prompt because I've had issues just recently with PowerShell on this machine. So make sure it's elevated so you're running it as administrator, just because later we'll be using some Hyper-V PowerShell commands that require administrator access. So at your command prompt, just go ahead and type docker run hello -world. And what you should see is it gives you that message that it's unable to find the image hello world latest locally. I'll just expand that so we can see. And so what it's gone and done is it's gone off to Docker Hub, which is an online registry, which we're going to have a look at in a moment. It's found the image called Hello World. It's pulled that down. So here you can see pulling, and now it's pulled down. Just one chunk is all it takes for this particular image. Once it's downloaded, so it says downloaded new image for Hello World latest, and then it runs the image. So all this output you see here is the output from running the Hello World process inside of that image. Let's have a look at the Docker Hub. So this link here, you can either Google for this or you can just type in that URL if you like. If you just Google Docker Hello World, you'll find this link. Let's click through there. So here we're looking at the Hello World image page on the Docker Hub. So Docker Hub, as I said, is a registry, online registry that hosts Docker images, and Hello World is one image. So in here we can see the information about the image. We can also see the tags for the image. We'll be looking at tags in more detail a bit later. But basically tags are like different, you can think of them as versions or variants of an image. Okay, let's do another Docker command. So this time we'll do a Docker pull. So Docker pull is actually what you guys have done, so you probably already know what this does, but let's just do this so we can explain it. So I'm saying Docker pull, and I want to pull the image called Alpine tag 3.5. Alpine is just a version of Linux. So when I go ahead and hit that, okay, I've actually already got this one pulled, but you guys probably won't, so you should see that download. This one's quite small, I think it's about 5 or 6 meg. This is useful if you just want to pull an image down, get it into your local cache, but not actually run that image yet. So that's Docker pull. Let's try some more commands. So now let's actually run, now that we've pulled Alpine Linux, let's go ahead and run a interactive shell in that Alpine Linux image. So here we go, Docker run -i-t, Alpine 3.5, bin/bin/sh. This is a Linux container, so it's forward slashes because we're running a Linux process. Let's just explain this command. So all Docker commands, now that we've got a bit more of a kind of involved command here, we can look at the structure of a Docker command. All Docker commands start off obviously with Docker, then the subcommand. So in this case, the subcommand is run. Any options you want to provide come next. So here I'm providing the option I, which is interactive, and T, which means connect a terminal to the running process. Then the image name. So the image I'm running is Alpine 3.5. And then optionally, if you want to run a process in that image, you can specify that afterwards. So I've said I want to run the shell, bin shell, inside that container. Go ahead and run, and you will be presented with a prompt. You're actually now inside of a running container. So if I do an ls-l, you can see I'm looking at a Linux file system. I'm no longer in my Windows 10 sort of environment. I'm now inside of my Linux container. And if I do who am I, I'm running as root inside that container. Let's drop out of that. Just type exit to exit that shell. And when you exit, you're exiting the bin shell process. Because you've exited that process, the container is now finished. It was running that process, that's what kept the container alive. Now that you've exited that process, the container is done. So we can see that if we do docker ps, ps is a Linux command for showing processes, so they've kind of used the same command name for docker. Docker ps, we don't see anything right now, but if we do docker ps -a, which means show all, then we'll see the exited processes as well. You can see status, it says exited. So my Alpine Linux bin sh process exited as soon as I exited the shell. Okay, next example. Oh, actually, yeah, so we're running a Linux container, and we talked before about how the operating system needs to provide the kernel to the running containers. We're running a Windows 10, so how is it actually possible that Windows can be providing a Linux kernel to my Linux container? It seems like magic. Well, actually, it comes down to the Hyper-V isolation we talked about before. If you bring up Hyper-V Manager, just search for Hyper-V Manager in your Start menu, bring up Hyper-V Manager, you'll see that there's a little VM there called Moby Linux VM, and this is used by Docker to run your Linux containers. They're actually running inside this VM, and it's then just connecting that sort of to your command shell. So it's actually remoting into that VM. So that's kind of where the magic comes from. The Linux kernel you're running against is actually inside that VM. But again, that's transparently happening through Hyper-V isolation. Okay, let's try some more basic commands. So we've run an interactive session just now. Let's try running a detached session. So if you're running like a web server or any other like service inside Docker, you don't want to run interactively. You want it to be running like headless, right? So let's run an interactive session of Nginx. I'm just going to switch to my other command up here. Here we go. So Docker run -d means detach. Nginx, by the way, if you're not familiar with that, it's just a web server. So it's like IIS if you're coming from a Windows background. So I'm running Nginx. I'm specifying 1.3 Alpine tag. So there's a number of different tags for Nginx. We'll take a look at this in a moment. And so I'm just running that as detached. It kicks off the Nginx process in Docker. I see this ID comes out. That's the ID of my container. And I'm now back at the Windows command prompt. We can now use Docker PS, as we saw before, to see that process running. So I didn't run Docker PS -a, just Docker PS. And I can see my container running, and I can see the status of this one is up 11 seconds. So this is a running process. Okay, it's running. I have no way to connect to that right now, so this is not actually that much use to me. So what I'll do is jump into that container, and I can use this little trick called Docker exec. So Docker exec lets me run a command inside a running container, and in this case I want to run the bin shell. Same process we ran before in Alpine. I'm now going to run that inside my running container. So I can do Docker exec command and -i -t. So it's the same as the command, the options that I passed to run before. I want to run an interactive session with terminal connected. The ID is the container ID. So here I can see the full container ID. I can copy paste that. I've got this short container ID as well, but I can also just provide any sort of substring, any initial substring of the container that's unique enough to identify my container. Right now I only have one, so I can literally just type even just 6. And that will be enough to let Docker know which container I'm talking about. So bin sh, and now I'm inside of my Nginx process. And I can check on that if I look at the file system here. If I cd, or actually if I just do ps -ef more here, I can see there's Nginx running. Okay, so Nginx is running. And I can also further check if I look in /etc/nginx. Here I'll see the config files for Nginx. So I am indeed inside of my Nginx container. I can see Nginx running. So that's how you can jump into a container, Docker exec. It's really quite useful when you're debugging. I use this from time to time. If I'm trying to get something working, one container won't talk to the other, I can jump into my container to check out what's going with the networking, or maybe check a config file, fix a config temporarily. It's really quite useful to be able to jump in. And you can do that both with Linux containers and Windows containers. If you wanted to jump into a Windows container, you would Docker exec into PowerShell. Instead of bin bash or bin sh, you would Docker exec into PowerShell. Any questions so far? By the way, guys, if you have any questions at any point, just yell out. Don't be shy. Okay, let's keep going. What's next? So we'll just look at a few other kind of housekeeping commands. We've looked at Docker PS, Docker stop. So if you've got a detached process, as we currently do, so there's my Nginx process still running. I can stop that by using Docker stop. Again, just specifying the container ID, 639. I also can specify the name. So Docker has given my container a random name here. So Vibrant Batani, whatever that means. You can name your container. So there's a -- name switch. We'll be using that in a lot of our other examples. But I could stop my container either by typing the container ID here or by typing the actual name. I'll just go with the ID, Docker stop 639. If I do a Docker PS again, okay, my container is stopped. And if I do a Docker PS -a, there I can see my Docker container now in the stopped state, exited state. Okay, if I wanted to remove some of these exited containers, I can use Docker RM. So if I do Docker RM, yeah, We can. Yeah, let's see that. So the question there was, can we assign those names ourselves? Let me show you how you would do that. Let me go back to my detached Nginx process. I want to add the dash dash name. Let's say I wanted to call this like web, dash dash name web. However, that option is in the wrong place. Remember the format that I said before, Docker, subcommand, options, and then image. So I need to put this switch before the image name. All right, so I have to go back here and put this back here, dash dash name, call it web, okay? And okay, I'm now running a new detached process. Docker PS, there it is, it's running, and you can see now my name is web, right? So if I wanted to stop that, I can say Docker stop web, and that stops that container. Yep. Any other questions at the moment? Yep. Yeah.
The Windows Docker has like an option where you can switch containers between Linux and Windows.
Yes.
It has to be something with this, like when you run the commands, should be on.
Yep. So the question there was, in Docker, you can switch between Linux and Windows containers. Actually, an interesting thing about Docker is it doesn't really change much the way you use it. All these commands that we're learning right now, we are running on Linux containers right now. In a few moments, we'll switch to Windows, and you'll see the commands are actually the same from a Docker perspective. So Docker is basically like a front end. Docker will talk to the Linux containers backend or to the Windows containers backend, and it will send the right commands to the backend to kind of fulfill what you're asking for from the Docker perspective. Does that answer your question? Sorry?
Yeah, actually, whatever we see on the tray on the right,
yeah.
actually has to do with the user interface of Docker, as I understand.
Yep.
To see different containers.
Yep. So down here we've got the Docker. Yep. So if I right click, I can switch to Windows containers. It says switch to Windows containers. By implication, that means I'm running Linux containers right now. If I switch to Windows containers, then I can no longer run my Nginx on Linux. I can only run Windows containers, but the commands from a Docker perspective are the same commands. We'll see that in a moment though. We'll do some actual hands-on examples of that in a few minutes. Yep. Okay, so we just tried Docker RM. Another one, I'll jump to this one, Docker container prune. This is a new command as of about 3 months ago, I think. It used to be really annoying because if you were doing a lot of like trial and error, you'd end up with like a whole list of exited containers, and people would write shell scripts to like iterate through those and RM them one by one. Now I can just do, hang on. Yeah, all my containers are stopped. So now I could just do Docker container prune. Try this out, and that will just, it'll confirm. That will just clean up all of those stopped containers. So if I do a Docker PS -A again, okay, all my old containers have been cleaned up. You probably would only be using this in dev. You want to kind of clean up your environment for some reason, you know, in production or, you know, a real sort of like test server, you probably wouldn't be using that so much. But for dev, it's really nice just to have that ability to wipe out all of your stopped containers. Let's look at the images side. So that we've looked at our containers, let's look at Docker images. This shows you the list of images that you've got currently cached basically on your local Docker server or your Docker daemon. So I've got, and you probably have most of the same container images as I do. I've got Microsoft ASP.NET Core, HA Proxy. These are all the images that you guys pre-cached for our exercises. And I've also got Alpine that I just pulled down. So yeah, Hello World is there. So if I wanted to remove some of these, like let's say I want to save space on my dev machine, I can use Docker RMI, so remove image. And let's say I wanted to remove Hello World, Docker RMI Hello World. Go ahead and run that. If I do Docker images again, so Hello World is now gone. And there's a similar image prune. So if I wanted to do, if I've got like a bunch of intermediate images, and you guys will face this once we get into some of our examples, I can do Docker image prune. It's a little confusing because images shows you the list of images, but Docker image singular, no S, prune is the commands to prune. And this would just clean up, it won't clean up all those images, just the images that are not tagged. Probably you guys don't have untagged images right now, but as we get into our later examples, you will see, you will have that. So that's our housekeeping commands. All right, so I think we've seen some basic commands now. We've seen the Docker command structure, got a few basic commands under our belt. Let's have a look at some more kind of interesting things. So mounting in external file systems. So when you're running a container, often you want to push or make available content from outside of your container. So for example, if you're running a website, you may not want to have the entire website inside your container. You may want to have the process to run your website in the container, but the actual web content outside the container, but mounted in. And that's where we can mount external file systems. So what we're going to do here is mount into an Alpine Linux container, just a directory from outside. So my working directory is, or my working drive is W drive. For you guys, it might be C drive, D drive. So just make the substitution for your machine. But let's go ahead and create in your working drive. So here in my W drive, I'm going to create a directory called data. And in there, I'm going to just create a text file. I'll call it foo.txt, and I'll just type in there foo, just so we've got some content in that directory. And now let's go to our command prompt, and we're going to run Alpine Linux with that directory mounted in. So let's go ahead and run docker, run interactive. So before we saw -i -t, you can actually combine these options. You can just do -it. You'll see most people kind of start to condense these together because it's good to save space. So -i -t, -v means we're going to mount a volume. So the volume we're going to mount is w/data for me, or for you it might be c:/data or d:/data, depending on your work directory. And that host volume, we're going to mount that into /data on the container. So the image is called Alpine 3.5 again. And again, we're going to run the same shell, so bin sh right there. Okay, so go ahead and run that. Again, this will drop you into the shell prompt inside the container, but this time you'll be able to go to, if you go cd/data, you'll be into the data directory you mounted. So again, that's the mount point for where you mounted your host directory. And if you do an ls-l, ls-l is like dir for Linux. Oh, it didn't work. Okay, this is good. It didn't work, so I can show you what's gone wrong here. In my case, it didn't work because I'm running Linux containers and I need to actually share my host my host drive with Linux containers. I'm going to dump out of that. You may have been prompted when you ran your container, or you may not have been. If you weren't, you may have been prompted to share. If you weren't prompted, so you're facing a situation like what I am, so you need to make sure that drive is shared. So I need to make sure my W drive is shared. So I go down here to the system tray and I go to the Docker applet, I go to settings, come in here to shared drives. It says it's shared. There is actually a bit of a glitch here sometimes. So I'm just going to go reset credentials, and it'll prompt me, so I cleared it, I'll reselect W drive, click apply, and it will prompt me to authenticate. So I'm just using my local work group here. And that's now shared. So I can close that, and now if I try running that again, this time it should work. Let's see. There it is, foo.txt. So that only applies to Linux containers, by the way. When you go to Windows containers, you don't need to do the sharing. It's only when you're working with Linux containers on Windows 10. All right, cool. So I can see foo.txt. I created that in the host, but now I'm seeing that in the container. Let me just do cat foo.txt to verify that it's my foo file. There it is. All good. And let me also write another file. So I can just do echo, let's say bar to bar.txt. So from my Alpine Linux container, I'm going to write a text file. Okay. And if I dump out of my container, exit out of my container exits. But if I go back to my host file system, there's bar.txt. So it was actually created from inside my container. So now you can see how we can mount a file system into your container. This mount option, we're going to be using this option to mount a host directory, and also we're going to create managed volumes later. The ability to mount file systems has a lot to it. So you can actually mount like an S3 bucket. You can mount all kinds of different file system types into your container. So as you get into more production scenarios, you might want to mount a SAN or a S3 bucket, so Docker can handle that for you. Okay, next externality is if we want to expose a port. So before we ran Nginx, which is a web server, it was listening on port 80, but actually there was no way for us to get to port 80. We need to actually map that port to the outside world so that we can access it. So let's do a similar thing to what we did before. We're going to run Nginx. We're going to run it with the interactive options this time, so we can see that Nginx log. And this time the new option is the -p. -p stands for publish. So we're going to publish port 80 from inside the container to port 8080 on my host. So let's go ahead and do that one. Just resize that. So Docker run interactive and terminal connected -p mapping host port 8080 to container port 80, and Nginx 1.13-Alpine is my image that I want to run. So this is now launched Nginx, and it's actually also set up a port mapping from my local host into the container. Now I can verify that if I go to my other command prompt, if I do a netstat -a, I'll do -an more here, I should be able to see, there it is, port 8080 on my local host is actually listening now. So that's my local host, 8080 is being mapped into port 80 inside the container. Let's try that in the browser. So if I go to Chrome here and I go to, let's say, localhost 8080, there it is. I've hit Nginx, and every time I refresh, you'll see, because I've launched my container with the interactive option and with the TTY connected, so I can actually see the log file coming out and stand it out. So I can really see Nginx actually running. Okay, what else do we want to do there? I think that's about it for port mapping. We'll be using port mapping quite a lot, so you'll see many examples of this as we go through our next examples. Final externality to play with here is environment variables. So if you wanted to set an environment variable inside your container, just close this. Let's say you want to basically provide some configuration to a process. This is one way people provide, let's say, a connection string to a Dockerized process. You can pass it in an environment variable. So you can use the -e option here to set an environment variable inside your container. So let's give that a try. I'll switch to this command, prompt. So Docker run, I'm going to run just Alpine and just set an environment variable so I can get inside my container and see that variable inside there. So I'm going to set foo equals var, and running Alpine again, bin-sh, same as before. So we're now jumping inside of our container. If we just do an echo $foo, then we can see the value of that variable has indeed been set. This is only set inside the container. It's not set on the host, okay? Only inside that container. Okay, let's jump out. Any questions, guys, about any of these options? The volume? Yeah, man.
Actually, what has happened with the file videos? Who was the writer and what's the access policy for them? So it's going to be a hypervisor?
For mounting a volume in Windows?
Yes.
I think you have to set a group policy to allow that. I don't have a note actually on what that is, but I can find that for you. I've got other notes about that I can share with you afterwards, yeah. And I'll add that into the slides actually. So
Can you control the access policy?
you can, yeah, you can. Any other questions, guys? Port mapping or mounting volumes or environment variables? Okay, cool. Let's move on to something a bit more interesting. So we'll get out of the basics now. We'll start to actually use Docker for something not really real yet, but getting closer to being real. So we're going to basically just create a website serving a page using IIS, which is a Windows container. So we're going to switch to Windows containers to do that. Let's go ahead and switch to Windows containers now. So to do that, you guys have probably already seen the option. Jump down here to the Docker applet, right click, and go to switch to Windows containers. It takes a couple of seconds to switch, so just give it a moment. And while that's happening, let's see what we want to do. we're going to use the official IaaS image from Microsoft. Let's have a look at that image on Docker Hub. Okay, so here's the IaaS image. It's actually published by Microsoft, so it's an official image. This is what you probably want to look for when you're looking for some base images. You want to look for something from the vendor because they will tend to provide updates more regularly. If we look at the tags, so when we're using the IaaS image, we have the option to use, is that still refreshing? There we go. We have the option to run either Windows Server Core or Nano Server. Obviously there's a big difference in size, so Nano Server is like a few hundred meg. This is compressed, by the way, so uncompressed it's about a bit over double that. Windows Server Core is 5 gig to download. We're going to use Nano Server because we're just running a simple site, so we don't need anything beyond just basic services. So this is our Docker file. Actually, at this point, guys, let's go to Git, and I'll just get you to check out the Agoda EX1 branch if you haven't already, just to make sure that you're on that branch. So that gives you the IaaS base content we're going to use. So what we're going to do is create what's called a Docker file. So a Docker file is how you provide like a definition of how you want to build a Docker image. And so this is our Docker file. We'll go through this step by step actually. So let's come over here. So in wherever you checked out the Git repo, come into the IaaS directory. And in here, let's just create a new text file. We'll just call it Docker file. This is the default name that Docker looks for. Docker file, no extension, so not txt, just Docker file. And open that up in a text editor. So I'm going to use Atom here because I've set the display settings so you can see it, hopefully. And so here we provide a set of like instructions on how to build our Docker image. So first of all, we're going to start with the base image. So we say from Microsoft/IaaS, and we can pick any tag we want. I've picked this tag, just a particular version. If you're doing something in production, you want to specify a particular version. You don't want to use latest because latest keeps moving. And if you use latest, when you build from day to day, you may get a different base image and that can actually break stuff. So you want a stable build for production, you should always specify a version. So for us, we're specifying this particular version that you guys have all pre-cached. So let me just type that in. Nano Server. So we're saying, okay, we want to create our Docker image from this base image. Once we've started with that base image, now we're going to configure the contents of the image by creating a directory inside there and basically copying. We've got this kind of default basic website here, this index HTML. We're going to bring that inside of our container. So let's go ahead and do that. So we're going to make a directory inside the container at c/site. And then we're going to configure, so I'm actually going to copy paste this just to save time. Using the PowerShell IS commandlet, we're going to set up an IS site pointed at that directory that we just created. And actually I'm missing one thing. Okay, I need to copy. Okay, hang on, I'm missing one directive. Let me just find that directive. Hang on. Oops. Just a second, guys, sorry. to cheat a little bit and grab my finished example. So by the way, guys, I've set up branches, so if you get stuck at any point, you can just jump on the branches to go to EX1 complete, go to EX2 complete for the finished working version. So let's have a look at my working image. Yeah, so here we go. So what I was missing was the add. So what this is doing is copying into my container everything from the content directory on my host into the site directory. And I'm also saying that I want to expose port 8000. So on my website, on my site that I've created, I've bound this new virtual site to port 8000. And now I'm exposing that so that this can be mapped to the outside world. And then I'm bringing in all the content from inside the content directory into the sites directory. Actually, that should probably say c/site, like so. Okay, let's try that. Okay. So once you've created that Docker file, you will make sure you're in the directory where you're working. So for me, it's wdrive/work dockerfoo and is. And we're now going to build an image from this Docker image definition. So the command here is docker build. And I'm going to tag this. So I'm going to tag it as, using the -t, I'm going to tag it as my/is. And we just say dot, meaning we want to build from the current directory. And that means Docker will look for a file called Docker file in that directory. Let's go ahead and see if that worked. It didn't work. Okay, what happened there? Okay. Okay, sorry guys. This was working before. I think I made a change I didn't retest. Hang on a sec. Okay. Should be, no, Mector is okay. Okay, anyone who can figure out the problem gets a bonus prize. Okay, that part's okay. That part's okay, so it's my copy that's wrong. No. Maybe it does need to be / like I had before. Okay, there was it. Okay, so /site instead of c:/site. All right. Cool. All right, so I've built my image from this definition. Let's have a look at Docker images and see my image there. There it is, my/is. It's by default been tagged as latest. Even though I didn't specify latest when I did my tag or my build command, it automatically puts latest if you don't specify. Cool, so now I can run my new image. So to run it, we can use this command. So this is just a Docker run command like you've done a couple of times now. We're adding a new option here. So --rm means that after the process is exited, it will automatically clean up the container. So you don't have to go into Docker PS and clean up the finished container. So sometimes when you're doing dev, it's nice to kind of auto clean up your container. So here we go, Docker run --rm. We're going to run this interactively so we can see the log output from IIS. We'll give this one a name. We saw the name switch before. We'll just call this IIS, and we're going to run the container my IIS. Okay. And it gives you this error message, but I think that can be ignored. And it says W3 service started, so let's try to hit localhost 8000. Oh, actually, hang on a sec. We should map the port, shouldn't we? Yeah, we should map the port. Let's run that again with -p. So remember we exposed port 8000. Let's map port 8080 to port 8000. So inside the container, we're listening on port 8000. Outside, we want to listen on port 8080. Kick that off again. Okay, so if I go to port 8080, oh man, sorry, I'm still running my Nginx. If you guys are still running Nginx, just do docker ps. Oh no, that was cached, okay. Kick it off again. That was a cached response from last time. Let me try it again. Third time lucky. Okay, do a shift refresh this time. Okay, now it says it can't reach the site. So we did what we did before, right? This time we've mapped port 8080 to port 8000. When we did Nginx before, we mapped port 8080 to 80 on Linux containers. But this time we're running on Windows containers. And the problem here is there's actually a flaw with Windows NAT at the moment. So you can't actually NAT through localhost on Windows 10. This is only a current problem. It's actually being fixed. So what we need to do is find the IP of the container and go directly. So to do that, we can use docker inspect. So keep your IIS running, and from another command prompt, let's do docker ps, just to verify our container is running. And then you can do docker inspect, and you can provide either the container ID or the image name. So this time I'll use the name, IIS. And that will dump out a JSON response from the Docker API that describes in great detail your running container. And conveniently towards the bottom, it gives you the IP address of the container on the bridge network. So this IP address is actually the IP address of your running container. So what we can do is grab that IP address, and if we browse to, instead of localhost, if we browse to that IP address, 8080. Ah, that doesn't work either. Man, what happened? Okay. That's working. Ah, right. So I have to go to the actual exposed port, not to the mapped port. So again, this is a problem with Windows and that at the moment. If I was outside my system, if I was from another machine accessing this machine, it would actually work. But because I'm on my local host trying to access locally, there's a little flaw in Windows NAT that prevents that from working. And I think later I've got some more details on that, so I'll show you that in more detail a little bit later. Okay, so what we've just seen there is creating our own custom Docker image. We've started with a base image, we've added into that a website, and then we've mounted into that web content from our host system. And we've seen running a Windows container, and we've seen that NAT issue, which will hit us once or twice. Any questions about this example, guys? Okay, otherwise I think we'll move on. Anyone want to take a break? I might just get a quick drink of water. Is everyone okay to take a quick break before we get into our next example? Is a much more kind of involved example. We're going to build a microservice in .NET Core running on Linux and Windows. So we might just take a 5-minute break. Yep, cool. All right. So for our next exercise, this is really starting to get into our real example. No longer just like the basic stuff. We're going to try to actually build a real application running through Docker. And we're going to run actually the same code on Linux and on Windows. And we're going to come up with a Docker file actually that will run on both. So what I'll get you to do is in Git, just switch to this branch. So git checkout to agoda_ex2. Check out. And we're going to do this one on Linux containers first. then we'll go back and we'll do it again on Windows containers. Most of the work will actually get done on Linux containers. So when we get back to Windows, it'll actually be pretty quick. So come back to your Docker applet and switch to Linux containers. While that's switching, let's have a look at the code for our microservice. So I've created a little web API microservice here. So if you look in the directory that you've checked out, the clone, you'll see a folder in there called tasks app. And in here, it's a very simple Visual Studio solution you can take a look at. Okay, so we'll just have a quick look at some of the code here, just so you kind of know what we're looking at. So we've got a controller class, a web API controller class that serves, here we go, serves /API/tasks, and also serves getting a single task, so you can request a task by ID. The IDs are GUIDs. I'll just quickly run this. The branch is Agoda EX2. Yeah. Agoda EX2. Make sure you've got that checked out, guys, so you have the code for this example. So when I run that, I'm just running that in IIS in debug, and there's my API. So there's two ways that this microservice will run. One is with an in-memory database, where it just generates some dummy data like this. And the other is we can actually connect it to a SQL server. So right now we're running with an in-mem database, and it's just generated some sort of sample data for us. So when we hit the API, it comes up like that. Does everyone have that running? Can you run that through IIS? Through Visual Studio? Cool. So let's kill that. And we actually don't need Visual Studio right now, so we might just sort of put that away and we'll come back to it later. So the first thing, we're going to go through kind of step by step first, building our app inside of a Docker container, and then we'll come back and do an alternative way to build using what's called multi-stage builds in Docker. So first of all, we're going to actually launch basically a .NET Core dev environment using a Docker container. So we don't need to install anything actually on our local machine. We can run it all through Docker. So this command here, let's basically run this. Once you've switched to Linux containers. Just back in your command prompt to switch back and go into Tasks app. And in here, we're going to run Docker run. I'm going to do -rm again because I just want the container to be cleaned up after it's finished. Interactive, and we're going to mount the host directory that we're in actually. So this has to be an absolute path. So I have to specify the full path. So for me, it's wdrive/work docker foo/tasks app. And also I'm going to mount it as the project directory. So mycode.tasks is actually the CS proj, the C# project. And I'm going to mount that into a directory called build, so /build. All right, so far this looks quite familiar. Docker run, auto remove, interactive, mapping the host directory where our code is into a directory called /build inside the container. The actual image we want to run is you can see ASP.NET Core build image. Okay, so there's two variants on ASP.NET Core. One is the build image, which has all the SDK, so you can actually compile .NET Core code with this image. Then there's the runtime image, which doesn't have the SDK. So we want to use the build image for now, but when we run this, we don't want to run our app in the build image. We want to use the runtime image, which we'll see in a moment. So the image we're using is Microsoft ASP.NET Core -build 2.0.0. And once we launch our container, we want to jump into a shell, so it's /bin/bash. This time, so this image is based on Debian Linux, so it has the bash shell. you remember before we were using Alpine, we had bins sh, so it's a different shell, but the same concept. So hit that, run that up, and you should be jumping into a bash prompt. So you should see root. Once you get in there, just jump into /cd/build. And you should see, if you do a ls, you should see the code from our project in there. Okay, so we have launched an ASP.NET Core build environment using Docker. This is actually already cool because we don't need to install any tools on our workstation. You can have a very minimal workstation and you can actually run the build tools inside of Docker. So now we can build our project. So you'll need to make sure that you're in the /build directory, and you will go to, you do a .NET clean. So .NET is already kind of set up inside this container for us. .NET clean, .NET restore, which it may take a few seconds because it will pull down a few NuGet packages. And then the actual build is .NET publish. We specify the release configuration, and we're sending this to a directory called out. So if I go back to my host file system, here in tasks app, in microtasks, I don't see an out directory yet, but when I run this command, it's going to start to build the application. It will actually create the out directory in my host file system. There it is there. And now it's compiling my microservice into that directory. Okay, if I look in out now, so there I can see my fully built and ready to run, actually, microservice. All right, once we've built, we're actually done with this container. We no longer need this container. We're not going to use this container to actually publish our app because this is the build container. It's got the .NET SDK in there. It's got a bunch of stuff we don't actually want in production. So we can actually just jump out, exit, throw this away. And now we're going to create our runtime container. So the runtime container, we're defining this in a Docker file, just like we did with our IIS example. This time our base image is the ASP.NET Core base image. Remember, we just used the ASP.NET Core build base image. This is obviously the kind of the same family, but this is the runtime image. It doesn't have the SDK in it. So this is good for running compiled apps, but not for actually building applications. So we're going to start with the ASP.NET Core image. We're going to make a directory inside of that. And we're going to copy the code we just compiled from our host system into the /service directory that we create. And we're going to then expose port 80, which just declares it as being a port that this container offers. And then we're going to use this new directive that we didn't see before called entry point. This is basically when you run the container, this is what's going to be executed for you. So it's going to run the .NET command line, passing your DLL, which is your web API microservice. So let's go ahead and put that together. So this will go in just in the root directory of tasks app. Over here, let's create the Docker file. If you want to skip ahead, you can git checkout to ex2 complete. If you want to jump ahead. If you want to build it up yourself, you can type it in yourself. Okay. I think I actually will skip ahead. So a couple of, let me just point out, hang on. Yeah, don't skip ahead because this is like the final one. Yeah, the final. You can skip ahead, but probably just drop out the first part, just keep this part. There we go. Actually, no, not even that. So I'm gonna copy from here. That's what I'll do. Docker file. So I'll just point out one or two other directives in here that we haven't seen before. So the first one is work dir. So once we start building the container, because we've created this directory called service inside the container, and we don't want to keep sort of referencing /service every time we issue another directive. So we can just say, right, from now on, for the context of this container, everything else that comes after this point is in the context of /service. Otherwise, we would have to do, here we would have to do /service. Down here we would do /service, so it gets kind of boring. So rather than doing /service all the time, we can say, hey, we're actually working in /service by setting that work directive. Then we're using copy. Last time we used add. This time we're using copy, so we're copying all the content from mytask/out. A little trickier, if you do / on the end, it will actually copy the entire subtree, but actually flatten it into a single kind of directory. You don't want that. You want it to be a directory tree, so you just do without a trailing /. Okay, so let's try building that. So back in our command prompt, let's do docker build -t, and we're going to call this one myco/API, and then dot again. So very similar to the build we did before. And have a look, read carefully the output. So first of all, you'll see each step coming through. First step is start with that base image, the ASP.NET Core base image. Inside of our new custom image, create a directory called service, set that as the default directory for all subsequent commands, then copy myco_task/out into the service directory, and then expose port 80 and set the entry point. So Docker images to verify that we've built that image. There it is there, myco/API. Now let's run our microservice API. So just to confirm, if I do Docker images, I can see there it is, Myco API latest. Let's run that guy. So Docker run. I'll do this interactively. And so we know that our microservice is listening on port 80. So we're going to map, let's say port, do this, 9871 to port 80. And we're going to run myco/API. That was the name that we gave, or the tag that we gave to our image. Okay. By the way, the ASP.NET Core images were updated like less than 24 hours ago. So it was funny because this morning I ran this one, and I noticed they're pulling a new layer, so they've actually just updated it. And I think what they've updated is this logging. I don't think this was there before. There was minimal logging before, so I may be wrong, but that's just what I noticed. Anyway, so we're now running our microservice. If we go to your browser and just browse to localhost port 80/API/tasks, hit that. It didn't work. Why didn't that work? Ah, wrong port, 9871. What am I thinking? 9871, sorry. There we go. There's the output of our API. And if you refresh it, you'll see, because we've connected interactively, or we are connected interactively to our running container, every time you refresh, you'll see the log file tick over in the background. Cool. Just note here as well, because we're using Linux containers, the port forward actually does work correctly. So we said 9871, and it's mapped to port 80. That's actually working through localhost. Remember, for Windows containers, at the moment, Windows NAT doesn't actually work properly. All right, cool. So we've got our microservice running. What's next for our project here? Let's see. Let's So we run that guy, browsed it. Okay, so the way we built that was we did sort of two steps. We did a manual build inside of a Docker container, and then we killed that, and then we did a Docker file, and we built our image from the output from the first container. So you can see we kind of had two containers at play. One was the build container, one was the actual runtime container. And we kind of did that sort of semi-interactively, so we logged into the first container and ran the build. But people used to do two Docker files, actually. A dockerfile.build, you can see dockerfile.build, which would be, if you look at the contents of my Docker file here, basically the steps that we just did manually, step by step. And people would do a Dockerfile build, which does the build process and then outputs to out directory, or even just keeps the content inside the container. And then, skip this part. Yeah, so we're not doing this interactively, but you would do a build using a Dockerfile build. And without even mounting a volume, if we just stored the build output inside the container, we can then use this Docker CP means Docker copy, to pull the content from the old container into a new container. So that's what people would do in the past, like basically run a build inside a container and then run a new container, copy the content from the build container into the new container, and then that would actually be the container that you run. This worked quite well, but it's obviously a little bit clunky because you've got kind of two Docker files, one's just for build, and there's a bit of like a kludgy step where you copy from one to the other. So in a very recent build of Docker, I think in 1705, this is now actually kind of supported as a first-class feature of Docker. So you can have what's called a multi-stage Docker file. So in a single Docker file now, we can actually specify a build stage where we start here with our build base image, and we do our build steps, and then we can add a run stage where we say a new from, right? So we're actually starting from a new base image, and here we're actually defining our runtime container. And the little trick here is that on the build stage, we've added this new little sort of metadata here, this directive that says the first image that we build, we're going to refer to that from here on as tasks-build. And then when we're building the run stage, as one of the steps in our run stage build, we can copy, and this -- from says we want to copy from the image called tasks-build and copy that into /build/out in our runtime container. So we've really combined two Docker files in one. The first one runs just to create the build, then Docker automatically copies from that one into the second build to give us the output. We're not going to go through and type this out, but I'll get you guys to basically, if you come back to your working directory, just kill your Docker file, delete your Docker file, and in your git bash, just check out Agoda ex2 complete, and you'll get the multi-stage Docker file. Check out So let's have a look at that. There it is here. Okay, so here it is. This is the same as what we saw in the slides. So the build stage, which does our build steps, and then the runtime stage. So what I'm going to do is, back in my command prompt, I will actually remove my Micro API image. So just do a Docker RMI. Actually, we may have containers left over. Yeah, so do a Docker container prune. Remember that one we saw as a housekeeping command? This is the one that kind of cleans up all your stopped containers. So go ahead and do a Docker container prune, and this would just clear all of the stopped containers. So we're back to like a clean state. Then we're going to just remove Micro API, that Docker image. I want to remove it just so that I'm sure that when I do this next build, I'm really seeing a new image there. So Docker images again, and I can see it's gone. Cool. And once you've done that, go ahead and run Docker build again. So the same build actually you did before. So Docker build, same tag, Micro/API, running from the current directory. But this time when you run it, just look carefully at the output because you're going to see that multi-stage build kick in. So first up here, you can see already that it's doing a build from the build image. Now it's running my build. Okay, and here we hit the second from. So now we're finished with the build image. Now we're working on the runtime image. And here we've done the key part, which is we've copied from the build image, which we aliased as tasks build. We've copied /build/out into dot, which is our work directory /service. If I do a Docker images here, we'll see this one here, this untagged image is actually our intermediate image. That's our build image. It didn't get a tag, but it was actually created as an image. If we wanted to, we could actually tag that. We could actually even run it. But it's just there as a sort of side product of our build. But there's our actual runtime image that was created for our API.
That's created off ASP.NET Core, because ASP.NET Core is only 7 MB, whereas ASP.NET Core build is 1.8 GB.
You can infer it. Yeah, you can infer it because ASP.NET Core build is like 1.86 gig, and this one is basically 1.86 and a little bit more gig. You can also see the created time. So this was created 24 seconds ago. This was created 23 seconds ago. So that was the first one that was created from my multi-stage. That was my build image. That's my runtime image. So this multi-stage build thing is actually really cool because it means you can have your build process and your runtime container definition in a single file. All right, let's just run that again, make sure that it still works. Docker run -it, map port at 9871 to port 80, myco/API. Cool, that's still working. Just a question from the audience here, which is, once we've done our build, as we saw, we've got two images were actually created. One was the build image, this one here, which has no tag. And one was the runtime image. So can we clean that up? Is there a way we can clean that up? Well, first of all, probably it's not a big deal to leave it there because you're not going to have this on your production server. This will be on your build server or on your dev workstation. And if you happen to do the same build again, let me actually do the same build again. It took about 200 milliseconds, right? Because Docker realized that even though I was running this extensive build process, all these steps, it already knows I've done those. And it's already got that image cached. It doesn't need to repeat itself. So there's actually an advantage to keeping those build stage images around. Unless you start making changes to your build process, you're going to get a very rapid run through your build if you do the same or similar builds more than once. So that's one reason you would actually keep it. But if you really want to get rid of it, so what you can do is docker images prune. Remember we saw the prune command before. That will, docker image prune, sorry, image prune, not images, image prune. That will clear out all the, what they call dangling images, which are images that don't have a tag. So if I now do a docker images, those ones that had none before, including my build image, are now gone. And if I run my build again, now we'll see it actually does take time because it's actually rebuilding that image that I just wiped out, okay? So, again, in your build system, so you would be running this on your CI system, your continuous integration server. Not a big deal to keep those images around. In fact, it's desirable because you can get speed benefits from that. You can save time. And in your dev workstation, similar story. Unless you're running out of space, probably just leave it, unless it's annoying you. It's maybe your list is getting too long and it's getting hard to see what's going on. All right, cool. So let's move on to the next step. In terms of time, hey Tim, it's 3:50. Yo Tim, 3:50. I'm just thinking maybe I was going to run this on Windows, but maybe I'll push onto Compose and so on. Keep going on Linux containers. What do you think?
Yeah, especially since we're the Mac.
Yeah, right. Good point. Yeah, cool.
But just you could do the same exact thing. You could take it about kind of like a take-home assignment, switch to Windows containers.
Exactly.
And run the
Yep.
same exact thing.
Yep.
All should work
Yep. So, by the way, guys, I'm going to update the slides on the GitHub so you can get the latest slides after today's session. I've made a few final edits compared to what's currently published. So you can work through all the examples again, but you can also we will actually skip the Windows version of what we've just done, just in the interest of time. But here's the steps. Once you've done the Linux version, you've actually done almost all the work. All you've got to do is switch to Windows containers, build it, and run it. It actually runs identically. So there's no change to the Docker definition. There's no change to your code. It just actually works. So you can try that out at home and see that working. All right, cool. So we're going to take what we've just built, this microservice, and we're now going to start to look at a much more production style deployment using Docker Compose. So let's say you've got an application that consists of a microservice API, but it needs to connect to a database. And in this example, I'm going to also show you running a HA proxy in front, a load balancer. So you've got a few containers. You don't want to be running them one by one with different Docker commands. You want to start to create like a meta kind of high-level definition of an overall system that consists of all of these containers in one definition. And that's what Docker Compose gives us. So Docker Compose creates a multi-container system or a stack. You define that in a single YAML file. And then to launch your overall system, you can just use a single command, Docker Compose, and tell it the file and just say up. So this is what we're going to build. We're going to take that microservice web API that we've just been playing with, and we're going to now run three instances of that API. And we're going to put a load balancer in front of it. HA proxy is a load balancer. And then we're going to put a database behind it. So all of this will be in a single file. We'll have a single file. We can just say Docker Compose up, and this entire system will come up in one command, which is pretty cool. So we're already on Linux containers, so we're good to go there. We're going to kind of do this in a few steps. Our first step will be just to create a Docker Compose definition that only contains a single instance of our API. And this is the definition. So what I'll get you guys to do is over here in your working directory. Actually, before we do that, we do need to check out another branch. So git check out ex3. This just brings in a couple of scripts that we'll use later on in the example. Okay, so once you've checked out Agoda ex3, let's create our Docker Compose file. So it's just a text file called Docker Compose with the file extension YML or YAML. And open that up in your preferred text editor. And just go ahead and create that file as we've got there in the slide. So version 3. There's several file format versions to Docker Compose. 3 is the current version. You can read the differences on the documentation, but unless you're really working with an existing legacy system, you would just always go with the current, so version 3. In Docker Compose, we define services. So your system is composed of many services. In ours, we're going to have an HA proxy service, 3 API services, and a database service. So our first service, we're just going to call API. And to start off with, we're going to define our API service just by saying build from the local directory. So that's similar to running the docker build command with the dot at the end to say we want to build the current Docker file. This is all we have to do. So with that Docker Compose created, let's jump back to our command prompt. And to build it, you'll issue a command Docker Compose -f to say which file you want to build from, and yours is called Docker Compose.yml, and then up to run that. When you run Docker Compose, you'll see it actually runs through your build process. So the same build process that we just ran by calling Docker directly against our Docker file, Docker Compose is actually running that for us to make sure that the image it runs is the current image. So it's just doing a build. This is very familiar to you now. This is what you saw before. And started building our cluster or our composite system so far with a single instance of our microservice. And someone's already noticed that we actually haven't mapped the port yet. So even though our microservice is running and it's listening on port 80, we haven't actually got any way to connect to that because the port is not mapped. So let's fix that. So over here in your command prompt, just Control C to stop Docker. One thing about Docker Compose is that it actually cleans up the containers. So if you do a Docker PS -A, I've got a couple, oh wait a second. No, sorry. If you do Docker, it cleans up when you do Docker Compose down. So up brings the system up, down tears the system down. So try that one there. Docker Compose down. Now if I do a Docker PS -A, there's a stale container from my earlier test, but the containers that were created by Docker Compose have been removed and cleaned up. So that's also quite nice. Okay, so what we want to do now is start to map that port for the API. So to do that, we're going to add a ports element to our service and map the same port we did before, 9871, map to port 80. So let's go back to our Docker Compose. So under the service, API service, under here we're going to add a ports key. And under there we're going to add this is an array, so it's a list of values. So we use the dash, mapping container port 80 to host port 9871. So having added that, let's go and run the Docker Compose up again. This time it won't do the rebuild because it's already got the images cached. So that's nice. It doesn't have to take up all that time again. Just brings the system up. Now if I go to localhost 9871/API/tasks, we see it's working, right? So it's working the same as before. Cool. Next, what we're going to do is add 2 more instances of our API microservice. So now make your Docker file look more like this. We've got that existing first one that we created, but now I've changed it to be called API 1. Not just API, but API 1, and I've added API 2, API 3. They're all the same, except I've mapped different ports. Okay, 9871, 9872, 9873. So we'll have 3 instances, all running under Docker Compose, but listening on different ports. Okay, once you've added those, Docker Compose up again, and you'll see, if you look carefully at the log output, you'll see it starts 3 containers. And so now we can go to port 9871, or port 9872, or 9873. And we know that they're different because each of these has generated its own sample data, so you'll just see different IDs basically if you go between them. So you can kind of tell that you're actually hitting different instances of the microservice. Also, if you take a look in your Chrome debug tools, you'll see there's a custom header called, where is it here? Node name, there it is. Node name. So there's a custom header there which tells you the name of the node. So as you refresh, as you hit, different instances of your API, you'll see a different node name, and that's actually the short version of the container name. So if you were to do a Docker PS in your other command prompt, you'll see here I've got a container called D79944, etc. That's actually the node name that's coming through in my custom header. so I can verify that I'm hitting that container. All right, that's cool. So now we've got these three API services running. Now we want to put a HA proxy in front of those. Oh, actually, before we do that, one thing you can do, I've said I want to build, every time I run Docker Compose, I want to build from my Docker file. And when I do that, let me stop my compose, stop my stack. So just kill that and just do a Docker Compose down again. If you look at your images, you'll see it's created a separate image for each of my services. Even though it's the same service every time, it's kind of creating a bit of overhead here, kind of wasted time. They all actually point to the same image, but they're different tags. So just a bit of a mess. So I prefer not to do that. What I'd like to do is to have it all being using the same tag. So I can specify the image tag in my Docker Compose. So let's go ahead and add that to our Docker Compose file. So same tag for each of our API services. It means that every time it builds, it'll just make sure that they're all using the same tag, so we don't get extra tags being generated. All right, cool. So now we've got our worker nodes running. Let's add the HA proxy load balancer. So this is a new service we're going to add to the Docker Compose. I'm going to put it at the top because it feels like it should be at the top. It's at the front of my stack here. So I'm going to add HA proxy. If you like, you can jump ahead to the completed branch. If you want to see the final product, it's Agoda EX3 complete. So what I'm doing here is I'm defining a service called HA proxy, using the HA proxy image from the Docker Hub, and I'm mounting a volume into this. So I need to provide configuration to HA proxy. And so I'm using a named volume. I'm not just using a local directory, I'm actually creating a named volume called HA proxy config, which I'm going to define in a moment. And inside the container, I'm mapping that to user local etc HA proxy. That's where the HA proxy process will look for its configuration. And I'm going to map port 9880 to port 80 on HA proxy. And I'll skip the other mapping. And here I'm going to link API 1, API 2, and API 3. What this tells Docker is that HA proxy is dependent on those other services. So those other services should be ready to go before HA proxy kicks off. Otherwise, it won't have the services to load balance. So that's my service, but I've referred to this volume where the configuration will go, but I haven't created that volume yet. So I need to skip forward to do that. I'll let you guys catch up with this part first though. So in this HA proxy service, we've referred to a volume called HA proxy CFG, but we haven't actually defined what is that volume yet. So now we need to go to the bottom of the file here, and we're going to define a volume. I think I've got that in a slide. Here you go. Called HA proxy CFG. And I'm setting this flag external. What that means is that, well, if it's not external, if it's not externally provided, Docker will automatically create the volume. But I don't want Docker to automatically create the volume. I want it to wait for me to create the volume because I want to put specific configuration into that volume. So by marking it as external, Docker will require me to tell it, okay, where does this volume actually point to? Right? So it's kind of like a little check, a safety check to make sure that Docker doesn't automatically create the volume. once you've added the HA proxy service and defined the volume, try doing a Docker compose up, and you should see the error relating to the external volume that I just mentioned, actually. So we've created our composite system. We've got 3 API services defined. We've got HA proxy. HA proxy requires config, so we've said, hey, we're going to provide you that config in our volume. And we've flagged the volume as external, which means that when we run Docker compose, we have to, or before we run Docker compose, sorry, we have to create that volume. That's our next step. Let's go ahead and do that. So to create a volume, back in the command prompt, we can say Docker volume create HA proxy CFG. And this will create a volume, and Docker will take care of where to store that volume. It's actually just storing it on the local drive of the Linux VM, actually, in this case. We can do Docker volume ls to see that it's actually there, to confirm that it's there. And I've actually written a script just to make this part a bit quicker called HA proxy copy config. So just go ahead and run scripts / HA proxy copy config, and this will actually use Docker to create an image that you can then use to kind of copy some files into that volume. It will only take a second or two. Okay guys, I think we're almost all up to this point. So we've created our HA proxy config volume. We've copied some files into it. I won't go into details on how we did that. You can see in the script the trick that's used there. And if you want to ask any questions about that today or afterwards, by email or whatever, or I can help you with that. But the next step is let's actually go ahead and now run our stack again with Docker compose up. So Docker compose. I'm specifying my file again. Actually, I don't need to specify the file because I'm using the default file name here, Docker compose YML. So actually, even if I don't specify that, Docker compose will find it. So I can just say Docker compose up, actually. That will actually work. What's happening here? Why is it trying to connect to the database? Okay, actually these are not errors. This is actually just HA proxy health check. So HA proxy, if you take a look at my config that I've created, HA proxy is a load balancer, so it wants to know if the nodes are actually healthy. And if one of the nodes dies, HA proxy wants to take that one out of circulation and send the request to the healthy nodes. So if you take a look at my HA proxy config, here it is. You'll see that I've set a health check here. So HA proxy will hit that URL to check if the node is responding correctly. And that's why we're seeing all that logging come out. So I didn't expect to see that, but that's what's happening. So this is not errors, this is actually requests from the health check. Anyway, so for us, we can now go to port 9880 after you've brought that up, port 9880, which is the listener of the HA proxy. Okay, that's the load balancer. And the load balancer is now redirecting to port 80 on the containers. So important to note that the HA proxy is using port 80. It's not using port 9871, 9872. That's only for us to connect from the outside. And again, if you want to look at the HA proxy config, you'll see that the load balancer here is connected to API 1, 2, and 3, port 80. So let's just experiment with that. So if I refresh, every time I refresh, because we're using still the in-mem database, we'll see different GUIDs come out. So we know that it's going through the round robin through those 3 nodes. And I can also check the node name header. Each time I refresh, I see a different node name. So I can be sure that it's going through the containers. How's it going, Tim? Networking? Okay. Is it like Fiddler or something? Or? Okay. Okay, guys, so all right, so we've got our cluster up and running. We've got 3 nodes. We've got an HA proxy. This is cool. I'll try to fit in just 2 more things. There's actually a lot more I wanted to go through, but we're running out of time, so we can have a part 2, or actually there'll be some more videos we'll put on YouTube of this stuff, so you guys can follow up later. We'll also have the slides on the GitHub, so you can also follow that. I'll show you 2 more things. Actually, I might just demo the first one, so you don't have to follow along. It's a pretty simple one that you'll get just by watching, and then I'll walk you through, and you can have a go at doing the SQL Server piece. So the first thing I wanted to show you is that with our Docker Compose as it currently stands, we've got ports mapped for our API services and for our HA proxy, which means that right now I can go to my HA proxy, but I can also still go to port 9871, 9872, 9873. This is actually not right. Like, I shouldn't expose ports to each of my web workers. I should have those kind of hidden, if you like, behind the HA proxy. So what I want to do is just remove those ports from the API nodes. However, if I'm in dev mode, sometimes I do want to be able to jump in and have a look at what's going on inside a particular container. So it could be convenient for me to be able to hit a container directly to see if it's working, to try issuing a request to it directly. So Docker has, Docker Compose actually lets you pass multiple Docker Compose files, and I'm not sure if I have the example. Yeah, here we go. So what I can do is create a second Docker Compose file, and which actually contains additional options that can get mixed in with my first Docker Compose. So I'll take these directives. I'm just going to copy paste this for time reasons. And here's my Docker Compose that I've been creating. I'm going to now create another file here called Docker Compose dev. .yml, and these are like additional options, if you like. And all I've done is, for those services that I've already defined in my main Docker Compose, I'm just adding the additional options to add those port mappings back. So let me run that real quick, show you how that works. So I'll kill my stack, Docker Compose down. Now I'm going to run Docker Compose. I'm actually just going to do Docker Compose up first. So Docker Compose up, because I want to prove to you that I'm not listening on those ports anymore. So if I do a netstat over here, right, I'm listening on port 9880, but not 987123. Okay, so that's proving that my removing those port mappings worked. But now I'm going to add my file specification. So Docker Compose YAML, and a second -f, Docker Compose dev YAML. And now that comes up, works the same way as before. But now if I do the same netstat, I can see all those ports are now open again. So you can have this dev mode kind of production cleanly separated in your Docker Compose, which is quite useful. Okay, that's the one. Probably just let me demo the last part. If you want to try to follow along, feel free, but otherwise I'm just going to probably crack on a little bit quickly with this one. So the last part is SQL Server. So right now, our API microservices are just using an in-mem database. So I want to connect this to a real database. So first of all, I want to create that database. So I've created a script for this, and it's in another branch, which should be Agoda EX3, X4, I think. Or X3 complete, maybe. Let me check. X4? Hang on. Let me just... Right. So I've got this script here. You can have a look at this. The command is in there for you to take a look at. It's called start SQL lin. So this is starting SQL Server on Linux. And so I'm just going to go ahead and run that. As maybe you didn't hear, but SQL Server, October 2nd last month, SQL Server 2017 was GA'd, and they're supporting Linux now, so you can run SQL Server 2017 on Linux, and you can also run it in Docker. So we're using the official Microsoft SQL Server Docker image to run the SQL Server, which is kind of cool. So my SQL Server has come up, and I will find my SSMS. What I've done with this startup script is I've mapped port, I think 1401. Let me just double check. I've mapped port 1401 to port 1433 inside the container, which means that I can go to localhost, comma for SQL Server, port 1401, and log in as SA. SA password is also in that script. Let's take a look at that. Super secure. You guys should always use a password like this. And there you go, I'm connected to SQL Server running in Docker on Linux on my Windows 10 machine. So I'm going to go ahead and create a database. I've actually got a script for doing that, so let me pull that up. So creating a database called tasks, and then I'm just going to create the table and inject some data into it. So if I just select, I think I just created that on the master database, but not to worry. I'll do that again. Oh, task, sorry. Okay, there we go. So I've got data in my database. So now I'm going to throw that SQL Server away, just kill that. And I'll actually remove it. Stop. Okay, stopping now. It's funny, I've seen some benchmarks that show that SQL Server actually runs better on Linux than on Windows. Just think about that for a few moments. Okay, my container's been cleared up, nice. So now I'm just going to make a change. So what I've done with my my microservice project here, I've added a switch. So if I'm running in production mode, I can cause it to use like a real database. So I just set that little switch to false, which means that if you take a look at my startup, it will actually use this connection string to connect to the database, looking for a host called DB. In this case, it won't be a host, it'll be a container called DB. So let's go and add that to our Docker Compose. I'm going to do that by checking out hang on. Probably already have it. So yeah, if I look at my Docker Compose, in my branch I've actually called it Docker Compose lin. So here we go. Bring that up. All right, so everything's the same as before, except we've now added this new service. We've called it DB. And we're using the Microsoft SQL Server for Linux image. A couple of environment variables. One is just to say we accept Microsoft's license. The second is to set the SA password. And then we've mapped the tasks DB volume. Hang on. Did I do that? Yep. So my script actually created that volume. And we're exposing port 1433, which means that other containers can use that port to connect. And we're also mapping port 1433 to port 1402 on the host, so we can also connect directly. So let's give that a shot. And where's this one? So Docker, I'm just going to run, I'm not going to run the dev settings, so I'll just run Docker compose up. Because I renamed it, so now I have to specify docker compose.lin.yaml. Okay, and you can see it's creating the tasks up DB. There it goes, came up. So I think that's working. Let's try hitting it. Hit it via the load balancer. And I'll just do wait, sorry. I forgot one step, which is I have to rebuild my code. I changed the setting, but I didn't actually rebuild the code. So let me, what I'll do is I'll just remove the old image, myco API. Take my stack down first, then I can remove the image, myco API. Now when I run my Docker Compose, I don't actually need to rebuild, because when I run Docker Compose up, remember, it will actually detect that I need to rebuild the image, so it'll do it automatically for me. So just rebuilding, so it's now using that external database instead of the EMEM database. Okay, back up, and let's try refreshing. Okay, here we go. So we're now getting the data from the database. We can see, if you look at the data that came out, this is the data that I inserted into the database. And I can also still verify that the round robin load balance is working because I've got that node name header. So I just got that response from container 54DE. Refresh again. Actually, let me shift refresh. Okay, from 3F19, shift refresh. From E1DC, so it's still going around. If I refresh again, we should be back to the first one, 54DE. So there you go. That is actually working. Okay. I guess probably have to finish up there because we're out of time. But you guys can follow through. You can try that example yourself from the slides and from the GitHub. I will push an update to the GitHub this weekend, and then I'll just post on the meetup page. If you guys want to just pull it down, you can try doing that one yourself. And sorry we didn't get to the Docker Swarm and AWS stuff. There's heaps more to go through, but you guys can probably try that from the slides if you want to. If you want to just message on the meetup, we can chat on the meetup page if you want to ask any questions. Also, I mean, if you want to contact me with any questions as well. So that's my contact details there. Feel free to email me or whatever. Cool. One other thing I'll actually point out is on my slide deck here, I've got, this is my recommendation, like to go from here to kind of learn more about Docker. This is the learning curve that I would recommend. So start with single container use cases. So you can start actually getting value from Docker just with very simple use cases where you're running a single service in a container. So some examples would be your CI system. So if you're running Jenkins, if you're running TeamCity, you can actually get official images for those and others as well that you can run in Docker. So actually recently, like 6 months ago or so, I moved my entire team city into Docker. So it's running inside Docker now, using those official images from JetBrains, which is quite cool. Your VCS, so if you're using GitLab, for example, or even just Git and SSH, you can run that inside of Docker. So again, you can set up a simple single service inside of a Docker container. Things like UpSource, SonarQube. Again, I'm pointing out that these are all available as official images. So you don't have to do much work to get these up and running. You can just go to the official image and get these up and running quite quickly. Even Plex, I don't know if you guys have heard of Plex or use Plex, but it's a media server you can run at home. Even Plex has an official Docker image, and it works really well. Once you get past those sort of single kind of services, you might want to start playing with putting some of your dev tools inside Docker. And then from there, the next thing I really recommend strongly is to study the networking stuff, because when you're doing these single service use cases, you're just using the default network bridge that Docker creates. So it's really easy. You just run it, you can hit the mapped port, there's nothing to really worry about. But before you go into anything like a clustered example like we've got in our slides that we didn't get to, you really need to understand networking quite well, because you actually start creating virtual networks inside Docker. You need to understand how DNS works. You can burn a lot of time, wasting time trying to set up your own DNS. Docker actually takes care of that for you, so you really need to learn that stuff. So I really recommend reading. These 2 pages are quite good. And probably once you're reading it, go through step by step and try each thing that they explain in a simple container. And then start looking at maybe more serious apps. Do some clustered or composite Docker Compose apps for your applications that you work on. Maybe start with tests and staging, and then once you're comfortable, you start looking at production. And the good thing about this approach is when you start off, you're actually getting value from those early use cases. Even the single, like just putting your version control, your CI into Docker is already giving you some value in terms of maintainability. So definitely recommend that. Okay guys, cool. Thanks for your time, thanks for coming. Hope you got something out of it. And again, feel free to keep discussing on the meetup page, on the TechAgoda meetup page. We can keep sharing questions and helping each other out as you guys keep learning. So thank you very much.